Alright everyone, so we're going to do our next lesson here. This lesson is going to be over polynomial manipulation and multiplying polynomials out. This is your book assignment. You guys will have this on the beginning of your packet. What I need you guys to do, let's go ahead and do this warm-up here at the beginning. This warm-up you guys will turn in to me. I will give you guys a grade for. Finding X and Y intercepts, just a reminder, the X intercept occurs when y is equal to 0, and you will find a mystery x value. And the y-intercept occurs when x is equal to 0, and you solve for some mystery y value. Okay. Next here we also have the slope of a perpendicular line. This will require you to do two things. First thing you need to do is you must solve for y. And after that you need to find the perpendicular slope. The perpendicular slope is given by the negative reciprocal. So remember, if we have a slope that is equal to 2, the negative reciprocal, or the perpendicular slope, will be equal to negative 1/2. Okay, let's see here. Let me get a different color pen, something that stands out a little bit more. Alright. Okay, once you guys are done with the warm-up, you'll turn that in on a separate sheet of paper, so bring that to next class and I will collect it then. For those of you that, let's see here, we have the homework, the 5.1 homework assignment is on here. So homework 5.1 was about, that was your exponents assignment that you guys had from last class, the class before the quiz. Here's the answers for it. This just happens to be on this packet. This normally isn't something that we find on the packets, but it is here. I'm going to give you guys a few tools that you guys can use in class to find answers. We'll talk about that next class, since I didn't get around to posting the answers for this particular assignment. We don't always have, you guys don't always have all the even answers in the book, so I'll show you guys some ways of getting the answers when I forget to post stuff for you. Alright, let's go to the next page then. Okay. Okay, so this is lesson 5.2, which goes over polynomials. We talked about this last time. We have monomials. Monomials are things that are only built by multiplication and division, so something like 3x squared yz. This is a monomial. Binomials are when we have multiple monomials connected together by addition or subtraction. So connected by addition or subtraction. Okay, so all of these down here are going to be polynomials. This one is specifically what we call a binomial. Binomial, like bicycle, means 2. So there's specifically going to be 2 monomials here. Okay, monomials. Okay, this one's a trinomial, tri being 3, like triceratops. So this is going to have three monomials. You guys will start hearing me use a slightly different word. I don't use monomials. Very few mathematicians actually use the word monomials to describe them. Monomials are actually the same thing as what we would call a term. Okay, so you'll tend to hear me use that word a lot. So a binomial, it's 2 monomials. I'm going to say it's a polynomial with 2 terms to it. So 1 term, 2 terms. Okay, 3 monomials, we don't say trinomial, we don't say 3 monomials. We're going to say this is a polynomial with 3 terms to it. Okay, so just some additional vocabulary there for you guys. Can you think of an example that is not a polynomial? Well, if we think of it this way, since polynomials are all 3 of these, including monomials, monomials are anything that you can put together that can be put together with multiplication. So you shouldn't be able to come up with anything that's not a polynomial. Okay? If you guys are able to think of one that I am completely forgetting about right now, tell me about it in class and we'll take a look at them. So, is G House wrong? Okay, so you guys can think about that one there, and if you come up with anything, let me know and we'll take a look at it in class. Okay, the next part of this is going to be the degree of a polynomial. So the degree of a polynomial is the highest degree of the monomial term. How do I want to say? So most of the monomial, or when we're talking about degree, most of the time we're just going to be looking at things that have a single variable. So we'll just be looking at x's. For example, let me turn the side here and you guys can see. So if I give you something like 3x squared, the degree is whatever the exponent is. So in this case, the exponent is 2. So this has a degree of 2. Okay, so If we go back to the examples here, though, these ones have x, y's, and z's. So when we have multiple variables in our polynomials, all we're going to do is we're going to take all of the exponents and we're going to add them together. So in this case here, your x, y, and z, we don't count the coefficients. So for x, y, and z here, the x has a imaginary 1 there, the y has an imaginary 1, and the z has an imaginary 1. So that gives us a total there of 3. So this has a degree of 3. If we look at the second example here, we have 2x squared y cubed. This term is going to have a degree of 5. And this one here, imaginary 1, 1 plus 1 plus 4 is 6. So this has a degree of 6. It is always the highest degree of any of the given monomial terms. So this particular polynomial here has a degree of 6. All right. Okay, let's go to the next page now. All right, so we have determining the degree of a polynomial. What's the degree? So we'll run through the examples really quick here. The highest degree here is going to be 2. This one has a degree of 2. This one has a degree of 1. There's no degree on this one, so this is a degree 2 polynomial. This one here, if we add them all up, this has got 5, a total of 5. This one has a total of 3 and a total of 1. So this is going to be a degree 5 polynomial. All right, this one here. So remember that whenever we have something in the denominator, we can always write it. Actually, we have the negative exponent rule from last time. So yes, we can rewrite this as a negative exponent. So this is the same thing as 3x y to the negative first plus 2x cubed y. This right here, that's negative 1. So negative 1 plus 1 is 0. So this actually has a degree of 0. This one here has a degree of 4. So this will be a degree 4 polynomial. Okay. All right, we'll keep going here. Let's see here. This one right here, we're actually going to skip this one because you guys don't know how to deal with this just yet. We actually don't know how. We haven't done square roots yet, so you guys have no way of solving this. I'll have to make sure I'm doing this in the right order. I'm pretty sure I am. Anyways, you guys don't know how to deal with square roots yet, at least from what we've covered in class. You guys actually can't do number 4, so just ignore 4. Okay. All right. Let's go to the next page now. So this is going back to what we did in the last lesson, just adding stuff together. So we did our smiley face thing, or apples and oranges, or however you guys want to think of it. It's just combining like terms at the end of the day. So if we add these together, the x's added together, we'll have 6x's. The y's added together, we'll have negative 8y. Okay. So just determine your like terms. Whenever you have parentheses and you have a negative in between, remember to distribute, or you're going to get the terms wrong. So this is really x cubed minus x plus 1. Distribute the negatives, gives us negative 3x plus 1. Distribute the negative to both terms. Now we can combine them. There's no other x cubes. We have two x terms. Negative x minus 3x is going to be minus 4x, and 1 plus 1 is 2. So that's the answer for that one. Okay, that's all the stuff that we did in the last section, so there shouldn't be any surprises on that one. All right, let's go to the next page. So we know how to add and subtract these things. Now we're going to talk about multiplying them together. Okay, so we have 2x, 7x squared. This is just a distribution problem. So we're going to let's first distribute. How do I want to do this? Whenever I do these, I always do them all at once. So when I distribute this 2x to each term here, I always do it in one fell swoop. If you need to do it in multiple steps, you can. I'm going to do it in one fell swoop here. If you have questions about it, let me know. So we'll do times the 7x squared here. 2 times 7 is 14. X times x squared is x cubed. And then that's that term. So the next term, 2 times negative 3 is negative 6. And then x times x is x squared. And then 2 times 5 is 10. And then there's no other x, but we still carry the x forward, so this will be 10x on the end. So that's that first one. Now we're going to harken back to some stuff that you guys probably did in Algebra 1 theoretically. So for number 2 here, this is what we call a FOIL problem. That stands for first, outside, inside, last. There's several ways to do this. Some people call it the rainbow method and stuff, but it's all the same thing. We're going to multiply the first two terms together. So 3x times x, that's 3x squared. Okay. We'll do the outside two terms. 3x times 5 is 15x. And then we'll do the inside two terms. Negative 2 times x is negative 2x. And then the last two terms, which will be negative 2 times 5, which is negative 10. Did I do that right? No, I didn't. There should be an x right here. Sorry. So 3x times 5 is 15x, not just 15. So that should be a 15x there. Okay. We can always combine middle terms. These middle terms will always be something we can combine. So combining those together will give us 3x squared plus 15 minus 2 is 13. So plus 13x minus 10 for our final value. Okay. All right. Next here we have our this is a trinomial by a binomial. This is a good method to do it right here. So on one column here we have the n plus 4, and in this row we have the individual terms of the trinomial. All we're going to do is we're going to combine everything together. So we'll just multiply straight across. So n times n squared gives us n cubed, n times 6n squared, n times -2, -2, and so on and so forth for the rest of them. It gives us a grid that we can work with, and then we'll just combine like terms from there. So if I combine all of these together, I will get n cubed, with the n squareds combined here to give us 10n squared, and then the n's combined together here to give us 22n, and then a minus 8 at the very end. So there we go. There's our first three examples for multiplying polynomials. The big ones here, I expect you guys to be able to do the distribution one. The distribution one is one that should be within your guys' realm of ability at this point. The FOIL problem here is also something. This we'll do some refresher on. If you guys don't remember this, we'll do about if we're seeing we're having a little trouble with this. I'll give you guys just a bunch of practice we'll do in class, and we'll get these out. You need to be able to do these because these lead to trinomials that have an x squared term and a single x term, which has a special name, which we call a quadratic, which is what we're going to spend a whole unit on probably towards the end. Actually, it's supposed to make up most of our trimester 2 content, but we'll see. It might carry it to trimester 3, but that'll be a big part of what we do for our Algebra 2 content. Okay. All right. This next part here, I am not going to do all of these. I am going to do actually only this first one. And then, as a surprise, I am going to ask you guys to do these two by hand, and you will turn it in with, where did I put it? Turn it in with the warm-up that you guys did earlier. So with this warm-up that you did on a second sheet of paper, I want you guys to expand these. And I will help you with the setup here, but you guys are going to have to multiply it out. Okay? So for this first one here, if we rewrite this, this is x plus y times x plus y. Okay. This is a binomial times a binomial. So you're going to use the FOIL method on this one. Okay. I'll give you guys the answers for this later. I want to see if you guys can do it right now. Remember, the middle terms condensed together. Actually, I'll give you guys the answer now, and then you guys can do these two here. The answer here, when you multiply this out, if you guys do it all correctly, should work out to x squared plus 2xy plus y squared. That's what you should end up when you FOIL this out using the FOIL method. Okay. If you guys don't get this answer, I want you to try it again. And then if we're still having trouble, talk to me in class, and I'll get you guys some more practice, and we'll talk a little bit more about this problem then. Okay. All right, let's talk about these two problems. These are the two that you will turn in with the do now problem with the warm-up. Okay. So this first one here is the same thing as x plus y times x plus y times x plus y. Well, if you remember, this part right here, this x plus y times x plus y, is the same thing as what we had in the first one here, and that's equal to this. So really what you're going to do is you're going to take this trinomial and you're going to multiply it by an x plus y. That looks an awful lot like number 3 from this example up here. So make yourselves a grid. In the column you'll put x and y. In the row across, we'll put x squared plus 2xy plus y squared. Do all of your multiplications and combine like terms. Okay? And then for the x plus y to the 4th, you're just taking your result from the previous one and you're going to multiply it by another x plus y. So that one you can also do using a grid, only instead of having, except that time, well, I'll let you guys try it. I want to see if you guys can do it, so I'm curious. So you guys can try doing the expansion of this, or a version of this, or another way to do it is you guys do x squared plus 2xy plus y squared, and you multiply that by itself. And you can do that using this lattice as well, and figuring that one out. I'm going to ask you guys to try that one on your own. I'll talk about that in class and see how you guys are doing. Is there a shortcut? There is a shortcut way of doing polynomial multiplication. And it is done by something called Pascal's triangle. Get all this stuff out of the way. Okay, so this is going to be kind of the last thing here that we'll do on this one, and then we'll talk about these practice problems in class. I'll probably save a couple of these for class, and we'll talk about that then. So let's see here. So here's what Pascal's triangle is. It's really a pattern, but something really interesting happens, and there's an interesting correlation between Pascal's triangle and multiplication of polynomials that you will see that comes from this. So first thing I want you to work on is making this thing. So the way that this works, we start with 1, okay, and the next row down is 1 and 1. Okay. The way Pascal's triangle works is this. The outer step, so the next step is going to have 3 terms in it. Okay, we're going to have a 1 on the outside, on the outside each time, and then in between the two of those, we're going to take the 2 numbers above. So the number that goes in the 3rd spot here in the middle is going to be the sum of these 2 numbers. So 1 plus 1 is 2. Okay, we'll do the next row. The outer layer is going to be 1. The next number is 1 plus 2, which is 3. Next number is 2 plus 1, which is 3. Okay, and then the outer number is going to be 1. Okay, and that pattern continues. So let's do it again. So we're going to have 1 here. So 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then there's nothing here for the 1 to attach to, so we just put another 1 down here. And it increases by that at each step. Okay, so you're just going to keep adding, you keep adding 1 at each step, and you keep growing this triangle. I would like you guys to do the next 2 rows. I want you to hit the pause button right now. Okay, hit the pause button on YouTube, and I want you guys to do the next 2 rows in Pascal's triangle, and I'll put down the answers here when you guys come back. You haven't pressed pause yet. I know you haven't pressed pause yet because you're listening to this. Okay, you pressed pause, and you did the next 2 rows. So those next 2 rows should be 1, 5, this would be 10, this is also 10, 5, and 1. The next row after that, the last row that I wanted you guys to do, we have 1, 6, 15, 20, 15, 6, and 1. All right, we'll stop there. We can keep going. And Pascal's triangle actually keeps going. There's actually some very interesting a field of mathematics that I studied a lot when I was in college called number theory, and we look at Pascal's triangle. There's actually more than what I'm about to show you here is just kind of the elementary stuff that we can do with Pascal's triangle. There's actually some very interesting things that come out of this particular structure, but that's a conversation for much later. All right, here's what this lets us do. Okay, if you will remember, x, I can write x. There we go. X plus y. I know this is glaring. I'll move my hand in a second and refocus it. So x plus y squared is equal to x squared plus 2xy plus y squared. All right. You will notice here that there are coefficients to these 3 terms. We have 1, 2, and 1. Okay, those are the coefficients, which you might notice is also the same as here. 1, 2, and 1. Okay, so here's really what you need to get out of this. Is this one right here is what you get when you have x plus y to the 0 power. This one is what you get when you have x plus y to the 1st power. Okay. This line is what you get when you do x plus y to the 2nd power, and so on and so forth. This pattern continues all the way down. So x plus y to the 3rd power, and this will be x plus y to the 4th power, so on and so forth, and that continues for the next 2 as well. But that's how Pascal's triangle works. So let's take a look at our examples here. All right, sorry about that. I had to take care of my dog real quick. Okay. Pascal's triangle, using this to do the expansion. So if you guys actually try to expand like some of these out like we did in those previous examples, like these ones here, so the x plus y, like these 2 that I asked you guys to do for a warm-up, you guys probably hate me right now because this is really tedious to do. There is a quick way to do it. In order to do it though, you need 2 things. You will need Pascal's triangle, and the other thing that you will need is the degree of the polynomial. Okay, so Pascal's triangle and the degree. If we have these two things, we can do these expansions really easy. So the degree of a polynomial, when it is written like this, when you have a binomial raised to an exponent, the degree is always going to be equal to whatever this exponent is. That's the first thing. You need that part first. So for this first one here, the degree is going to be equal to 3. You need to know that. Okay. Next, what we're going to do is we're going to go to the degree 3 line. So the x plus y to the third, 1, 3, 3, 3, 1. And we're going to write this down. Every single term in the expansion of these has to have a degree that totals up to whatever the degree of the polynomial. So every single term has to have a degree equal to 3. So the very first term here is going to be x to the third. This has degree 3. Okay, that's good. The next part here is going to be plus, so we're doing degree 3, so we're going to do 3 here. We'll have a coefficient of 3. And then there's going to be an x. The x is going to drop by 1. So we had degree 3 here, so this x is going to be squared. So we will have an x squared there, and it's going to be multiplied by the other number, by the other part of the other term of the binomial, which is a 2. So we get 3x squared times 2. Okay, we'll go to the next term now. The next term is going to be, again, our coefficient is going to be 3. We reduce x again by another 1, so we will get just x here. But 2 is going to get the other one. So I know I said before the coefficients don't have degrees to them. For our purposes here, what I'm really saying is the terms. The total of the terms have to come up to that. So the 2 had an exponent of 1 on it. In this case, it's going to have an exponent of 2 on it. So if I total all the exponents up in this term, it's going to still add up to 3, because there's still an imaginary 1 on the x, 1 plus 2, so I still have a degree 3 polynomial, or a degree 3 term here. Okay. Alright, the next term is going to have a 1 in front, and it's just going to be, because this one here will have a, so let's do it this way, so we'll have a 1 from Pascal's triangle. The x, we're going to reduce the exponent by 1 again. So this had a 1 on it. Now it's going to be x to the 0. And that's going to be multiplied by 2 cubed. Okay, so we have our two terms here, and we're going to expand it out. I'm actually going to show you guys a slightly different version of this one, and then you guys can play around with these examples, and we'll see how you guys are doing. So if I multiply everything out here, I will get x cubed plus 6x squared. And then we're going to have 2 squared is 4, so this will be 12x. And then this last one here will be 2 cubed, which is 8. Okay, so that is the expanded polynomial for x plus 2 cubed using Pascal's triangle as our shortcut. Now, if you want to confirm this, and I think you guys do. No, you guys don't. Oh, darn. You guys can try expanding this out by hand. Okay. Actually, I'm going to pause the video here really quick, and I will do this on the back side of this paper. I'm going to do it by hand, and I will show you that we end up with the same exact value as we had on this side. Alright, here we go again. So, we were expanding x plus 2 cubed. We got this x cubed plus 6x squared plus 12x plus 8 using Pascal's triangle. So we had a degree 3 polynomial. So we go to the third line. We have 1, 3, 3, 1. That gives us the coefficients. So we're going to take the, oops, you guys can't see that. So let's go here. So we have x. So we're going to break this into two parts. We have one term that is x and the other term that is 2. We start off with the first one. We're going to cube that, make it equal to whatever the 3 is. Then we're going to start combining them together. So we'll drop the exponent on the x. So that's how we get the x squared, which means the exponent on 2 is going to increase by 1. It was at 0. 2 raised to the 0 is just 1. So there's really a 2 to the 0 here that I didn't write in. And then we're going to add in the coefficient from Pascal's triangle, which is 3. Do that all the way across. We ended up with, when we combine like terms, x cubed plus 6x squared plus 12x plus 8 for our complete expansion. If I do it by hand, x plus 2 cubed is the same thing as x plus 2 times x plus 2 times x plus 2. FOIL the first two terms together. I'll get x squared plus 4x plus 4. Got to multiply by the x plus 2, so I set up a lattice. The x and 2 make up the column, so x and 2. And then x squared, 4x and 4, x squared, 4x and 4. Then I multiply it, so x times x squared gives me x cubed. So on and so forth. X times 4x is 4x squared, x times 4 is 4x. Do the same thing with the 2's. We get all of these. We can always add together these diagonals, and we will end up with x cubed. 2 plus 4 is 6, so that gives me the 6x squared. 8 plus 4 is 12x, and then the 8 at the end, which matches our answer from the other side. Okay? These next ones, I would like you guys to try these next three on your own, and regardless, I will go back over these in class. So I will take some time at the beginning of our next class and make sure that I go over examples 2, 3, and 4 with you guys. All right, we'll cut the video there. That takes care of your notes for the time being. Remember, you guys have got stuff to turn in for me. You've got the warm-up, and you have those two problems that I wanted you guys to practice on the expansion of polynomials. And then you guys can try these three on your own, but I will go over these in class if you guys aren't able to figure them out. Be able to make Pascal's triangle. If there's one thing you can practice until our next class, it's actually making this. Remember, 1, then 1, 1, and then 1, 2, 1, and it comes from the sum of the two numbers above it. So 2, 1 is 3, 1, 3 is 4, 3, 3, 6, so on and so forth. Be able to create this. Okay, this makes multiplying these really big nasty things much, much easier later on. All right, I'll see you guys in class.